So, Mod 5 is about quadratics, and with that, for whatever reason, they recommended I start at 5.4. So, let's first start with this section right here. What is a quadratic? In a quadratic, the function will always have a U-shaped graph. The highest power on any x has to be a 2. It can be no higher or no lower. It will either be in the form of f of x equals ax squared plus bx plus c, or f of x, if it's in factored form, is a times the quantity of x minus n times the quantity of x minus n. So make sure you write those things down. We're going to use this form in a variety of ways. We're going to use this form in a variety of ways. So both forms are pretty darn important, okay? Now, you may recall that with quadratics comes the word parabola. Parabola means that it is a U-shaped graph with mirrored symmetry down through the vertex. So what I mean by that, if you want to put a little dot here, those 2 points would be considered the vertex. And we could fold this kind of like a butterfly down the center of the butterfly. We could fold that down the line x equals whatever that vertex's x happens to be. Now, your parabola shape will go up if this front a value is positive, whether we see it attached to the x squared or we have it out in front. If the a is negative, you will see your parabola shape upside down. So you have to realize that the a not only affects kind of the width of our parabola, but the a will determine if it's flipped upside down or not. If it is positive, our parabola will go upward. If it's negative, our parabola will go downward. So what's great about the symmetry, once you know the vertex, if you are equally spaced on each side, you're always going to be at the same height. So once you know the vertex, you're going to be equally spaced as you go and it gets progressively wider. Now, it's also important to know what the vertex gives us. The vertex gives us the maximum or minimum value of the parabola. If you I'm going to add one other form. Could you guys go back up to this spot? Let's write f of x equals a times x minus h squared plus k. That's a third form we could have it in. As we eventually start working on transformations of functions, this is a nice form. And the reason it's a nice form is we see that a, which is going to determine if it's going upward or going downward. We also see our h and k, which is our vertex. Now, if you aren't visibly going to see what the function's vertex is, if you can't see that h, if it's not showing itself very clearly, there's a calculation we can always do to find the x value of our vertex. That h value, that x value is always negative b over 2a. That h value is always negative b over 2a. Okay, so that's important to know. We can always calculate that vertex, and I'll show you different ways to find that vertex. Finding that vertex is one of the most important pieces of the puzzle. The vertex is always evenly spaced between any, let's say our function hits the x-axis. The vertex is always evenly spaced between anything that is at the same height. So that can be another way we can find the vertex. Because of the fact that our symmetry goes through the vertex, we can also say that the parabola has symmetry about the vertex. You can fold it over the line x equals that vertex number, that negative b over 2a. So you're going to see that negative b over 2a happen again and again and again. Okay, you'll see that negative b over 2a happen again and again. Okay? So all of those pieces of information are going to be super important as we go through this process. You may recall the quadratic formula. If this part of the quadratic formula is 0, you might recognize our negative b over 2a is in there. Okay, but let's talk about the quadratic formula. If you want to solve for the roots or zeros of the quadratic formula, if it is factorable, you don't have to use the quadratic formula. So if it is of this form that I had written earlier, you know that it's going to be zeros at x and n. Because it's in factored form, it's really great. Factored form is our goal. You don't have to use a quadratic formula unless it is not factorable. There's not too many different ways we have to solve for the roots or zeros of a quadratic unless we use the quadratic formula or we do something called completing the square. Now, most people don't like completing the square. That's not their favorite technique, but we will talk about that way to always solve a quadratic's roots or zeros. But it's a very useful formula. So let's talk about it. One thing to note, you want it in descending order. You need your x squared to come first, then your x, then your number equals 0. Okay. The coefficient on your x is your a value. The coefficient on your, or x squared is your a value. The coefficient on your x is your b value. The number hanging off the end there, that constant, is your c value. Watch when you plug it in. Now, I'm going to give you some keys when we get down further and we do some examples together. But I will do some of the pieces as I go so that I am less likely to mess up the order of operations. So I'll give you those hints as I go. I taught Algebra 2 for many, many years, and I always kind of saw what my Algebra 2 students messed up in the quadratic formula. So I'll remind you of those things to be careful for. But this is very helpful and is what you can use to find those roots or zeros if this is not an option. That should be your first thing. Can I factor it? But if you can't factor it, that's the way we want to go. Okay, so that is some important information, some important vocabulary that you're going to see related to quadratics, parabolas. So those formulas will be helpful. And as you go through the homework that's coming up this weekend, having those formulas and those examples next to your math, your iMath, would be very helpful. Okay, so that is some of the vocabulary we're going to be using and some of the formulas we're going to need. Okay. Yes. Mm-hmm. We can also, well, I'll talk about that when we do another section. I was going to add a little piece of information, but we don't need it just yet. Yes.
So I was working on my mathematics. I used some late passes. I didn't realize that I'd already completed the assignments that I used late pass on.
I can always add some back in if we need them, so don't worry about that. I'm not concerned about if we use a million of those things. Okay, are we good to go with the information you see there? Okay, so now let's talk about some examples. We're going to talk about graphing them. We're also going to talk about some, if the equation looks like this, what we can do. I'm going to call number one our parent parabola. That's the one that gives birth to them all. That is the most basic of our parabolas. That parabola, if it's in that form, what I always suggest doing is to find that symmetry, plug in -1, 0, and +1. Now, this is a parabola that is like the perfect shape. it has a vertex at 0, 0. If you plug in 0, you get out 0. If we go an equidistant away from 0, we are going to get at the same height. So if you plug in -1, you get a height of 1. If you plug in +1, you also get a height of 1. That should always happen because of the symmetry of a parabola. That's what makes a parabola a parabola. So if I go 2 away on each side, -2 and +2 both are at a height of 4. -3 and +3 are both at a height of 9, and so on, okay? So let's just plug some of those, or draw those. So it's at 0, 0, that's our vertex. So let's label that vertex. Now, when a parabola is pointing upward, when our a value is positive, we always have a minimum at that point. And that's a very good application when we see some of those word problems we're going to see about parabolas. So at -1, we are at 1. At +1, we are at 1. We could even plug in at -2, we're at 4. At +2, we're at 4. At -3, we're at 9. At +3, we're at 9. We don't need to be that specific, but for this parent one, I want to get you the sense as close as we can to what we see. Now, the axis of symmetry here goes through the vertexes x. Our vertex for this one was 0, 0. Our axis of symmetry is x equals 0. You can see that we can fold it like a butterfly across, and both sides match up perfectly. Okay. Now, here's the problem with one like number 2. Number 2, we have some issues. We have a negative out front. We should expect that it should be pointing downward. So this negative, that a value is -3, and it's pointing downward. If there's only an x squared term and no x term anywhere, if there's just an x squared term like this one, the vertex still happens always at 0. That's our vertex. You can still just plug in 1 to the left and 1 to the right of that value. When there's only an x squared term, it is always having a vertex at 0. If you plug in 0, you get 27. We are going to have to alter our, our graph paper a little bit. We'll mess that up in a minute. If you plug in +1 and -1, you should get the same value. If I plug in +1, I get 24. If I plug in -1, I get 24. Okay. So our x's are okay the way they are, but let's take our y values and let's count. Let's count. I don't know. Let's make this 20, and let's make this 40. Let's make this 20. So 5, 10, 15, 20. That's 1, 2, 3, 4. 1, 2, 3, 4, 5. So I'm technically counting by fours. So 4, 8, 12, 16, 20, 24, 28. Is that right? I can't even. Well, so 24, 28, 32, 36, 40. Yeah, so we're so that's kind of how we're counting. Okay, so let's put our 0, 27 on there. At 0, we're at 27. It's just below the 28 mark, so about right there. At -1, we hit 24, which is this mark. At +1, we hit 24. That symmetry should always happen. Okay. We could try to see, where you hit the x and y axis. I believe we hit them at 3. I believe that these are the points that we hit. We're not going to mess with that right at the moment, but that is another way we could look at the graph. Okay. So if it's just an x squared term, plug in +1, -1, and 0. Your vertex is always going to be at 0. The problems occur in graphs like 3 and 4, so I really want to talk about 3 and 4. If it is in factored form, like number 3, we have some very specific things we can and cannot do to help us. So I'm going to start with 4 and move backwards into 3, okay? Let's start with 4. The first thing we need to do is find the vertex. Remember that x value, that h value, is always negative b over 2a. So we need that number. So our a value is -1. Our b value is +3. Let's plug that in. Okay. So if I plug in, our b value is 3. So the opposite of that goes on top. 2 of our a's go in the bottom. So that is our a value is -1. 2 times that is -2. So that is at 1.5. Now, normally I like 3/2. 3/2 is great, but if I have to graph something, I need a number. So I do, that's where sometimes I will actually write a decimal. Okay. Now, that is our center of the things we are plugging in. So I definitely have to plug 1.5 in, something above it, something below it. Okay. Well, one half step up is 2, half step down is 1. As long as they're equally spaced, that's just nice numbers you can plug in. You can plug in anything into a quadratic, but I try to find that equal spacing so I can see that symmetry of my graph. Now let's plug in 1.5 to begin. So you're just taking out the x's, you're inputting 1.5. Okay, so it's the opposite of 1.5 squared plus 3 times 1.5 minus 6. So that is negative 3.75. Now this parabola should be pointing downward because of that negative out in front, okay? If you plug in 1, you get -1 plus 3 minus 6. I get -4. Now if I plug in 2, if I picked right, I should also, because of the symmetry, get -4. If I don't get -4, I did it wrong. But let's check. If I plug in 2, I get -4 plus 6 minus 6, which indeed is -4. So a parabola kind of checks your work for you based on the symmetry. If you pick the right vertex and pick a point above it and below it that are equally spaced, you should always get the same value or something is wrong. Okay. So at 1, we are at -4. And at 1.5, we are a -375. And then at 2, I'm at -4. So my parabola looks something like this. Okay, it is pointing downward like I expected. Its vertex, this point right here, is the highest point of the graph, so that is our maximum value. Our vertex, when our a value is negative, is always a maximum value for the entire function. That kind of helps us if we wanted the range of this function. The range of this function is from -infinity up to that height of -3.75. The domain of a parabola is always all real numbers. Okay. So now I want to go back to problem number 3. Okay. Now I want to go back to problem number 3. Now, if it's in factored form, they are actually giving us the zeros, but not the vertex. Okay. So I know that this function equals 0 when x minus 2 equals 0 and when x plus 4 equals 0. So it gives us one thing, but it's lacking the vertex. But I know that it hits the x-axis at 2 and at -4. So I have some very good points, right? I know it hits it at 2 and -4. I know that these x's are positive, so it is going to be something shaped like that because it has to be pointing upward, it has to go through those points. The vertex has, because these are of equal height, the vertex has to be smack dab in the middle of that. So let's count. 1, 2, 3, 4, 5, 6 spaces occur between -4 and 2. 6 spaces occur between -4 and 2. So 3 spaces, so smack dab in the middle of that, that's here. -1 is the halfway point. So let's plug in -1. We know the vertex has to be -1 something. And we know that because of the fact that the symmetry of this means that if I have two zeros, one at 2 and one at -4, the symmetry line has to be smack dab in the middle, which occurs at -1. If you plug -1 in, you get -3 times +3 or -6. So now I found 3 points. I have a perfect graph. Did I do it wrong? That is not how you multiply, Mrs. Hahn. I love the faces. 3 times 3, last I checked, is 9. How about we do that? That's better. There we go. Okay, so now we have that point. At -1, we are all the way down here at -9. And then we can put on our parabola. Now, what's another way we could have graphed this? Well, if we look at our function, if we were to distribute and multiply out, that's the same as x squared plus 2x minus 8, if we were to FOIL it. So in that form, we can do exactly what we did for number 4. We could do the formula -b over 2a. We would get an -b over 2a value of -1. We could plug in positive or 0 and -2, but we wouldn't have those nice points where we hit the x-axis quite as clearly as we do when it's in factored form. So there's lots of different ways to graph these. You probably graphed last year in Algebra 2 quadratics quite a bit. So I'm hoping that this is ringing a bell as to how to graph these functions. So now let's practice finding roots. Now roots are, remember, it is where the function equals 0. You can either use the quadratic formula or you can factor. I always try factoring first. Now, if we revisit the problem that I think we did right above it, this is just like this is number 3. We already determined the roots. That is where the function equals 0. And then it becomes a super easy process. Whereas x minus 2 equals 0, whereas x plus 4 equals 0, that's at 2 and at -4. These are the points where we hit the x-axis. Remember, roots, zeros, x-intercepts, vertical intercepts are all the same thing. Remember, those were vocabularies that all go together. Roots, zeros, x-intercepts, and horizontal intercepts were all the same thing. Okay. But number 6 is unfactorable. There's no way we can factor that. There's no factors of 5 that add up to -7. 5 is always 5 times 1, which always adds up to either +6 or -6, depending on what sign you use. So it's not a factorable thing. When that's the case, we must use the quadratic formula. You've got to use the quadratic formula. Okay, so our A value is 1, our B value is -7, our C value is 5. Because remember, that's that AX squared plus BX plus C equals 0 thing. We're looking at where is that equal to 0. So in that case, we're going to use the quadratic formula. Let me give you some hints on how to use it. Let me write it down. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Now our a value is going to be 1, our b value is going to be negative 7, our c value is 5. Do some of the pieces in your head. Negative b in your head, what is the opposite of b? So b is negative 7, negative b is positive 7. Do the next pieces in your head. Usually these numbers aren't so giant that you can't do that in your head. What is the quantity of negative 7 squared? Negative 7 squared is negative 7 times negative 7, 49. Do that in your head. Do negative 4 times a times c in your head. The next piece is negative 4 times a times c. Do it in your head. Or if you're doubting your math skills, grab a calculator. Negative 4 times a is negative 4 times 1, negative 4. Times c, 5, is negative 20. Do that in your head. All over 2a's. Do that in your head. 2a's, 1a is 1, 2a's is 2. And if you do what I just did, you are less likely then to mess up the next phase of things. This function hits the x-axis at whatever the quantity of 7 plus square root of 29 all divided by 2 is, and 7 minus the square root of 29 all divided by 2 is. Here's how you can check your work, okay? You could go into Desmos. You could graph this function. It better hit the x-axis at 2 and negative 4. You could graph this function. It better hit the x-axis at whatever those decimal values are. Now, Desmos will show those decimal values, I think, either out 4 or 5 decimal places. But if you put those in a calculator, either put this in parentheses, do the plus, then hit equals and divide it by 2, or do the minus and then divide by 2. Yes? So okay, so let's go over the how we're going to do it one more time. This is the opposite of b, so that negative 7 becomes a positive 7. We're going to square the b, so that becomes a 49. Then negative 4 times a times c. I like to do that in my head. Negative 4 times 1 times 5 is negative 20. If it becomes a positive, put a plus between them. Do that number, and then if you can reduce that radical, reduce it. You can't always reduce it. You're kind of stuck. So I tend to kind of do that. Remember, that's always the opposite of what you see there. That's going to flip that sign. Did that answer that question? Okay. Everybody good with 5 and 6 and how we use factoring or the quadratic formula to find the roots or zeros? Okay. So now I want to do a word problem. So please look at number 7. Let me read it to you. It says, Frozen Treats Ice Cream Shop finds that its weekly profit in dollars P as a function of the price it charges per ice cream cone in dollars. X is modeled by the function K of X, where P is K of X. And you see that the highest power is a squared. That tells me it's a quadratic. The A value is negative. It's a quadratic that's upside down. So when you look at that, that's the first thing you're going to do. Let's highlight some important things about this function. Okay, so we need that. Remember, X is dollars. P is profit in dollars. Okay, we're going to make ourselves a little note that X is the price of an ice cream cone. And P is the same as K of X. And it is the price or the amount of the profit. Okay, so I always like to pull out the information from that word problem. It's not a bad idea if you have a highlighter on your iPads, of course, in in Notability, you can highlight whatever you want, but to pull out that information is helpful, okay? And it says, find the maximum profit and the price of the cone that will produce this profit. A maximum or minimum of a parabola always occurs at the vertex. So if you ever see any type of quadratic equation problem mention, find the maximum, find the minimum. Always find the vertex, okay? So if we are to find the vertex, remember, the vertex's x is always negative b over 2a, okay? So if we look at this function over here, our a is negative 350, include the sign. Our b is 3,700. So let's pull those numbers out. Let's plop that into that equation, okay? So that is going to be negative 3,700 over 2 times negative 350. If that's something you can do in your head, just do it. 2 times negative 350 is negative 700. And you should expect that a price, remember x is the price of a cone, you should expect that it should be something that is a positive number. You know, you're not going to give money to the person with their cone. And that is a very expensive ice cream cone, rounded to the nearest penny, since it's money. The price of the cone that it will maximize profit is $5.29. Let's assume it's like a really large, giant ice cream cone. $5.29, okay? But do you see what it says here? Find the price of the cone. That's what that is, because that's what our x is, and that little note helps us. But it also says to find the maximum profit. The profit is the y value that goes with it. So now we just have to take and plug in that 529. Okay, so we're going to do negative 350 times 529 squared plus 3,700 times 529 minus 7480. Okay, so let me put that into a calculator for you. And we get that the profit, or the profit when we charge $5.29 for a cone, rounded to the nearest penny, is $2,298.57. Okay? So we've answered both things, and it's important that we understand. We could even put a little sentence, and we could say, if we charge a price of $5.29 for a cone, we will make a maximum profit of $2,298.57. So putting the words with that is a good idea when answering a question like that. Now, how can you check your work? Here's my suggestion. Now, if we didn't use x's, I would probably change. Well, you have to change it for Desmos to x's. And you'll notice that the top of our I could probably have changed the settings. I should have, but yeah. I'll keep scrolling. I'm hitting it almost. I'm close. Remember, it's that 2,000. I'm getting there. I'm almost at the 2,000 mark. What was it? 22.98. Oop. So look at that point. $5.29 was our x when rounded to the nearest penny, 2 decimal places. $2,298.57 is the y value that goes with it. So using Desmos to verify your work is a good idea, but you should know how to do the algebra that goes along with the graphical interpretation, the geometry. Those two things should always verify each other, or one of them is wrong. Okay? Okay. So there you go for Desmos. Now it says, when will the ice cream shop break even or make a profit of $0? So remember, that is where the function equals 0, okay? Now we can solve that with the quadratic formula. I'm going to set that up for you, but for time's sake, I'm going to show you how to use Desmos for that as well. So that would be negative b. So remember, our a value is negative 350. Our b value is 3700. Our c value is 7480. Let's use the quadratic formula to find this value. So it's negative b, or the opposite of b, plus or minus the square root of b squared. Now it's a very giant number. It's 13,690,000. Minus 4 times a times c, I'm going to do on my calculator, minus 4 times a times c does end up being a negative. That tells me I'm going to subtract. So that's 10 million. And all over 2 a's, which is negative 700. So we get negative 3,700 plus or minus the square root of 3,218,000 all over negative 700. Now, for a moment, let's talk about what we've got here, okay? If we divide a negative into a negative, that's a positive. If we divide negative into the positive version, that's a negative. You gotta see, what numbers you get. If I do, so let's change the signs of this. I wasn't going to do it, but then I kept going. I'm so sorry. Okay, so let's do the square root of that big number. Let's see what we get. If we get a bigger number than 3,700, we don't, okay? So this is approximately 1793.88. Okay, so we get 2 times, okay? When will they make a profit? So that is, okay, so let me tell you, 3,700 plus 1793.88. I'm going to do the addition first. Divided by 700 is 785. Let's do the smaller one. 3,700 minus 1793.88 divided by 700, all divided by 700 is 272. Okay. So at the 785 mark and the 272 mark, they don't make any more profit anymore. One is too high, one is too low. They're not going to make any money. So if we go back to Desmos, and I got to go back. Oh, there we go. Look, 272. Look, 785, when rounded. Where we hit the x-axis, our zeros, our horizontal intercepts, our roots, all of those things tell us where the profit, the height is 0. So it says here, when will a cone cost too much and they will lose money? So anything over that 785 makes our profits go down into the negative. That's the highest it will be. That's when it's too much. If it's below 272, they're not even covering their cost of their workers and their ice cream cone supplies and things. So that's where that 785 and that 272, that kind of separates when they make profit and when they don't. The best price they should be charging their customers is $5.29. The 2 worst prices are $7.85 and $2.72. Okay. Now it says define the function formula that generates. So that's the end of our word problem. we're running out of time, but let's try to do number 8. If we have to continue tomorrow, we will. But I think we got enough time. We'll get this in. It says define the function formula that generates a parabola with horizontal intercepts at -5, 0, and 3, 0 that passes through the point 2, 3. So when it gives me intercepts, I am always going to use this version that I showed you up above. Okay. So our intercepts are -5 and 3. So that's going to be -5 and 3. Okay, so the m and n are -5 and 3. They've solved that for us. So our equation looks something like this: x plus 5 and x minus 3. It always becomes the opposite of what those intercepts, those roots or zeros happen to be. Now, we're done as soon as we know what the a value is. So that's where they have not used this 0.23. We're going to use that 0.23. When I plug in 2, I have to get out 3. That's what you have to think about. That's what a point gives us. So when I plug in 2, I better get out 3. Okay, so look what happened. When I plug in 2, I better get out 3. When I plug in 2, I better get out 3. Do you see how our only variable is a? This will allow us to solve for a. Then we got our equation. Then we're good to go. Okay. So this is a times 7 times -1 has to equal 3. Or -7a has to equal 3. So now we know what a is if we just divide by -7. So a is -3/7. Okay. So what's our equation? Let's fill in everything we know. Our a now we know is -3/7. We have the x plus 5 and the x minus 3. And then graphing is very easy. We just go to 5. We go to -3. Smack dab in the middle of those things is 1. If you plug in 1, I'm going to tell you what we get if we plug in 1. We get 5 and 1/7. So if you plug in 1, our vertex is there. But it should also hit the point 2, 3. So I'm so not doing a good job, but okay, so we hit, -5 and 3. I'm like, something is not right. -5 and 3. So our vertex is at -1. Like that wasn't right. We go through the point 2, 3. Our vertex is at 1, and I believe, or -1, I think it's right here. Yes, that looks so much better. Okay. So we can use lots of things to give us this. If they give you the intercepts, that's always how you can find the equation. That a version is the equation that you want. So there you go.